Good afternoon, everyone, once again. I'm Joseph Michael Okori, and I'll be making presentation on developing genetic biocontrol policies and guidelines key to mitigating misuse and promoting public acceptance. As you all know, it is a picture of a typical Lagos in Nigeria and how the activity is very rousing in Lagos. So that's how the problems we have about mosquitoes. If you notice from this, a lot of activities, you can deduce a lot of information from this picture. You see how rowdy it is. So that's how problems in Africans are, and in Nigeria to be precise. Then with this problem, now, if there's effective policy or regulations, you discover that these people will be moving in a seemingly on a very good way, in such a way that there won't be any form of cohesion. So if there is effective policy or regulation in any technology, you will definitely agree with me, this will address a whole lot of stuff in addressing so many emerging technologies. So this big guy is the big brother for Africa. Yeah. Why I say it's the big brother for Africa is because it has killed more human than any animal. So, and that is the problem we are actually facing in Africa, particularly in Nigeria. The economic loss for Africa is over 12 billion annually, $12 billion annually, while that of Nigeria is just almost 5 billion annually. Of course, Nigerians are taking the lead in this regard, though on a very bad note. So with this now, you can see this picture. I so much love this picture, and that's even the summary of the presentations. You see a whole lot of people doing what they're supposed to do, part-time, per seconds, no any form of cohesion. So when we have effective policy and regulation, definitely whatever problem we face in Africa, in Nigeria, will be definitely addressed, where everybody needs to know what to do part-time, per second. Malaria remains an ongoing health challenge with over 600 deaths in 2021, of which approximately 96% occur in Africa. Despite concerted efforts, the goal of malaria elimination has stalled in recent years. This has resulted in widespread calls for new control methods. Genetic biocontrol approaches, including those focused on gene-drive modified mosquitoes-based approaches, are aimed to prevent malaria transmission by either reducing the population size of malaria-transmitting mosquitoes or making the mosquito less competent to transmit the malaria parasite. However, this developing genetic biocontrol policies and guidelines is crucial for ensuring the responsible use of genetic technologies in managing pests, diseases, and invasive species. These policies not only help mitigate potential misuse, but also promote public acceptance of biocontrol methods. These are some of the genetic biocontrol approaches that can be used to address the issue of malaria. One of them is classical biocontrol, which is the control of a pest through the release of a natural enemy of that pest, to the genetic biocontrol, a type of biocontrol that uses genetic variants or genetically engineered forms of the pest organism themselves as the biocontrol agent. Then the gene drive, a process that promotes inheritance of a certain genes from generation to generation so that they increase in frequency within a population. Then the population replacement, a form of biocontrol that reduces the ability of the target vector species to transmit a pathogen. Then we also have population suppression, that's population reduction, a form of biocontrol that reduces the population size. Then self-limiting gene drive, a system that imposes a temporary restriction on the inheritance of the modifications. Self-sustaining gene drive, localized gene drive, a system that imposes a spatial restriction on the spread of modification through a target vector populations. So why is genetic biocontrol useful against malaria? Of course, over the last 2 decades, malaria-affected countries have achieved remarkable success, but the fight is not yet over. The sources that have been recovered so far is as a result of the use of ITN, that's the inserted treated net, the inside residual spray, avoidable diagnosis, and case management, improved livelihood, chemotherapy. For us in Nigeria, the Honorable Minister for Health has reported recently that Nigerian case is complex because most of the drugs are resistant, and you need about 3 to 4 anti-malaria drugs to be able to treat malaria in Nigeria. That's the report from Nigeria. Then also, Nigerians have got about 26% of all cases, which is governing about 76 million cases, and Nigeria have 31% of all death cases, which is around 192,000. Of these, 80% of deaths are children under age 5, and 1 child dies of malaria every minute in Africa, of which Nigeria is taking daily because Nigeria governs about 96% of the such cases. The efforts are complicated, yes, which I've said. Resistance to commonly used insecticides, the plasmodium resistance to commonly used insecticides. These insecticides in Nigeria and maybe perhaps other African countries, you agree with me, most people don't even like using them. I don't like using them on a more serious note because once I sleep in them, I feel somehow. And sometimes, again, some people in Nigeria, again, you see them, they use it in their farm. So that intervention have actually failed. Yes. So when you make policy, look at policies that are going to what people want, which the people are not consulted. So the purpose of this net has been defeated because they are now being used for other things too. Facts on malaria in Africa. Every year, mosquitoes kill more people than any other animal. African region carries a high share burden of the global malaria. One tool that is being considered in the fight against malaria is the genetic modification. Several research projects around the world are looking to use genetic modified mosquitoes to stop the spread of malaria in Africa. Malaria is endemic and all populations at risk getting infected. Burkina Faso experience, of course. Our brothers from Burkina Faso will understand that much better. Malaria is a preventable disease, and yet so many lives are still lost. A child dies from malaria every minute. I re-emphasize that. Of course, a release anywhere is likely a release everywhere. How genetic gene-drive modified mosquitoes have been developed. Of course, ever since the conference began, we've been talking about gene drives, and we know that these are natural occurring processes. Is sexually reproducing. It leads to a particular genetic sequence. Biases is inheritance in its favors, and even if there's any fitness cause associated with the sequencing. The whole goal is that the sequence is present more widely in population within a few generations. As you can see, the first standard inheritance, which is the Mendelian's law, which will give you about 50% of such inheritance in the mutations, while the use of gene drive also will give you almost 100% in the mutation too. So gene drive, it has so many applications. It cuts across our health environment, it cuts across our agriculture, and also the RNA-guided gene drive too. So the whole essence is that the engineered and synthesized gene drives, that's the whole essence. And that has been done with the use of modern biotechnology. And emphasis has been given over time since the conference began. Why genetic biocontrol in Africa? Worldwide, there are more than 3,500 species of mosquito, with over 600 of them in Africa. Of these 4 very closely related species are responsible for the most of the malaria cases. Unfortunately or fortunately, Nigeria have all the host species in our own area. The genetic modification of mosquito has the potential to be a powerful ally in the fight against malaria. Technologies are being developed that could help reduce the number of mosquitoes that carry malaria by making them less fertile. For instance, by reducing the population of the mosquito, we hope to reduce malaria transmission. I've said this, it has really in Africa have lost over $12 billion annually, and in Nigeria over $5 billion too. So it has caused a lot of economic loss. It has affected other sectors in Nigeria and in Africa too. So this is a typical example of Nigeria and how the various species have been spread. So during the trials or any form of trials, you look at some particular areas have more species, some particular areas. So it is expected when policy is being made or when deployment is being made, those areas that have more particular species, trials should be carried out in those areas than others too, as depicted from these diagrams. Then the factors to be considered before developing an effective policy and guidelines on genetic biocontrol. We've actually know that over the years, we keep talking about stakeholder engagement. What is stakeholder engagement? Who is even a stakeholder? It's a real concern for us, because when we talk about stakeholder engagement, people's mind wants to go towards the buy-in of top management staff or the buy-in of politicians or the buy-in, forgetting that a stakeholder is someone that actually have influence over a group of persons. If I can push you to do something that is not your way, mean that I'm a stakeholder over you. So, but the problem we are having is that considering other policies have been developed, we don't have much stakeholders carrying along much of the stakeholders. As low as a clerk in your office can even influence a greater decisions while working in the office. You will agree with me. So in developing this new technology, we must ensure that we bring in everybody that needs to be on the board, and it should not be exhaustible. As soon as we identify a new stakeholder, you should be involved in part of the process in developing these policies. So the Research Institute, what we need is inclusive dialogue. We also need public consultations. We also need regulatory agencies. Like for us, I'll give instances of what is going on in Nigeria, where we have developed our own policy on action plans. That's the NBMA. What we do in the NBMA is that for us to have a particular document in NBMA, we've brought in over 100 stakeholders. Some of these stakeholders cut across various MDAs, that's the Ministry, Department, and agencies. So whereby such is not being involved or is not around, you discover that such will not fly. When you hear such will not fly, you think it's playing, meaning that the person will definitely kick against such policy when it arises. I'll give you instances of what happened in the National Assembly. A document was brought for review to repair some laws, so as to gauge, and some of them are not around. It passed the first reading, it passed the second reading. Getting to the third reading, someone just remember, wow, that these people need to be part of it, the NBMA, that in which even the legislature even gave them. So if they are not being carried along constantly, you discover that whenever there is any form of law governing such new technology or which have been given before, which they want to read over, definitely it will not fly because it will be kicked against by such stakeholders. Another thing again you look again is that most of this stakeholder engagement is not just about having stakeholders engagement. We also need to know that we should constantly engage the stakeholders, even prior before the release of any form of technology. Or while it's ongoing, the stakeholders should also be involved to know this is what at the stage we are, this is where we are. So it's not be a one-time stomp, it will be an ongoing process engaging them too. Then the risk assessment and management. Comprehensive risk assessment is being required, and monitoring evaluation is also being required. Then this is the component of the risk assessments. The first speaker have actually highlighted the problem formulations. In the risk assessment, the key thing that we need to know is that the problem formulation is an integral part, and it should also be communicated to. That we have the risk content, we have the risk assessment, which includes the problem formulations, the risk management. Indirectly, that will give us the full component of the risk analysis. So in the problem formulations, what we have is the protection goals. That's identify protection goals and make them operational. Such protection goals are human health, that cut across human health, animal health, environmental health, soil health, water quality. Also operational specific goals, which include ecological entity and attribute to protect, maximize tolerable impact, and spatial are important to do that. So in that of protection goals, we have event A, where environmental release of gene drive modified insect. That will lead to event A, never lead to event B. So if that never lead to event B, which is over there, event B lead to event C within an acceptable frequency. So event C leads to harm within an acceptable magnificence. That's the end point of anxiety. So automatically now, the key aspect in formulating policy should be strictly on after stakeholder risk assessment, steps of problem formulations, which is actually key. And when that is fully in depth, you'll be able to have a response policy that will address some of these emerging technologies. These are the key components of biorisk, which are the biorisk assessment, the biorisk mitigation, and the biorisk performance. The risk that will be conducted will be evidence-based risk, which means gather information, we evaluate the risk, develop a risk control strategy, select and implement risk control that you have developed, review the risk and risk control measures. It runs in a cycle like that. These are the potential risks. So regulatory framework. Clear regulations and transparent regulation governing the development, release, and monitor of genetically modified organisms used in control. We need adaptive management. Incorporate adaptive management practice that allow for policy adjustment based on new scientific evidence and scientific feedback. We also need the regulatory bodies. We need to strengthen the regulatory bodies to oversee the gene drives regulation. This will support proper assessment and monitoring too. Ethical considerations have been said. Ethical guidelines need to be developed. Equity and justice will also ensure informed consent, and community must be understand the potential benefit and any possible risk. Local knowledge Local knowledge and concerns should guide deployment strategies. Ethical concerns and around transparency should be addressed and clearly communicated. Of course, public education and communication. Then international collaborations. Collaboration with international organizations such as the WHO, the African CDC, the FAO, and international committees on harmonization on this technology. We need knowledge sharing, research and development, crisis management. Then the most important thing which I want to highlight on the issue of long-term sustainability is this: sustainability is key, because some of these policies we make, we should also consider how are they going to last. And in the sustainability, we have to look at co-sustainability, coexistence. Who are the people to own this technology? Because if these policies and regulations regarding to this technology is not sustainable, definitely it will not have the light of the day. The regulatory pathways for gene drive. Then, example of evidence-based drafting on this. I'll just explain this because we have a scenario of lack of regulatory framework for gene drive technology. What is unknown about the scenario? What might happen after the scenario occurs? For lack of relevant regulatory framework, we know we have focus, parameter to be regulated, unknown political goodwill or political buy-in, inadequate knowledge within the legal fraternity, suitable different testing sites for different stages. That will lead, these factors will now lead to what we call delayed decision making, potential risk to human and animal health, inadequate data, conflicting institutional functions. For us as a team Nigeria, our ongoing discussions in this policy is going forward is perception about malaria situation in Nigeria, what works for us, and so other countries also have to look into what works for their own countries, challenges, insight about the gene drive modification in mosquito, insight on the best way to package gene drive to meet our specific need. 2, how should research and implementation be regulated? Who should regulate? How long? What are the best strategies to build and improve capacity for managing this technology? What capacity is necessary? And who should invest in the technology? In conclusion, the development of genetic biocontrol policy and guideline is a multifaceted process that requires careful consideration of scientific, ethical, and social factors. Thus, by fostering stakeholder engagement, ensuring rigorous risk assessment, promoting public education, and encouraging international collaboration, policymakers can create a framework that mitigates misuse and enhance public acceptance of genetic biocontrol technologies. This proactive approach will ultimately contribute to more effective and suitable use of biocontrol technologies for malaria control. These are my appreciations. Thank you.